Hello, dear students. Here Ashfaq Patan, Department of Angadi Institute of Technology and Management, Belagavi. So, in last class, I was discussing the even and odd concept of minus pi to plus pi. So, I have solved one example. Okay, now let us discuss the second example. The example is find the Fourier series for the function for the function for the function f of x is equal to 1 1 1 plus 2x divided by pi in minus pi to 0, 1 minus 2x divided by pi in x lies in between 0 to pi. So this is the example. You have to find the Fourier series for this one. So if it is given in a double function, how to check the Fourier series? So for that one, you have to start with taking the first function as let phi of x. Phi of x is equal to 1 plus 2x divided by pi, and psi of x is equal to 1 minus 2x divided by pi. As I told you that the example is minus pi to plus pi. The example is given minus pi to plus pi. So therefore you have to put here. So you have to put x is equal to minus x. Okay. So as I have it is in the double function. So you have to take any one of these two function. So let us start with let phi of x is equal to 1 plus 2x divided by pi. Now in this put x is equal to minus x. So phi of minus x is equal to 1 plus 2 into minus x divided by pi. So this can be written as 1 minus 2x divided by pi. And you observe here 1 minus 2x divided by pi, which is nothing but psi of x. So therefore psi of x you got. Therefore phi of minus x is equal to psi of x. So if it is a positive, then the function becomes, therefore the function is 1. If the function is even, so therefore if the function is even, so bn is equal to 0. You need to find a naught and n. So for that one, so let us take a naught formula. A naught is equal to 2 divided by pi integration 0 to pi f of x into dx. So this is the formula for a naught. So therefore 1 2 divided by pi integration 0 to pi. The function f of x is defined here too. So out of these two you have to take any one of these two. The interval is 0 to pi. What is the interval here having? 0 to pi. So therefore the corresponding function will be 1 minus 2x divided by pi with respect to dx. Now see here 2 divided by pi. Okay, now integration of 1 with respect to x is x minus 2 divided by pi is constant. Integration of x is x square divided by 2, applying limit 0 to pi. So therefore 2 get cancelled. So 2 divided by pi bracket x minus x square divided by pi bracket. So applying limit 0 to pi. Apply that limit. So let me solve here. So 2 divided by pi, apply upper limit, pi minus pi square divided by pi, upper limit minus lower limit is 0. So therefore 2 divided by pi bracket 1 pi it cancel, pi minus pi again it becomes a 0. So therefore it becomes a 0. So bn is equal to, sorry, a naught is equal to 0. So finally you got a naught is equal to 0. Now let us move for further calculation for an. So an can be calculated like this. The formula an is equal to 2 divided by integration 0 to pi f of x into cos n x with respect to dx. So 2 divided by pi integration 0 to pi f of x is 1 minus 2x divided by pi into cos nx with respect to dx. Therefore 2 divided by pi, so bracket. Okay, apply the Bernoulli's rule. First function as it is, then integration of cos is sin nx divided by n. then minus, then differentiation of this one is 0, differentiation of this one is minus 2 divided by pi, then integration of sine is minus cos nx divided by n square. Okay, then again differentiation of this term becomes 0, so let us move applying limits 0 to pi here. So therefore 2 divided by pi as it is bracket. So if you substitute these two, the sine function becomes 0. So what is remaining? Minus into minus plus, plus into minus minus, minus sign remains outside. 2 divided by pi n square, 2 divided by pi n square is a constant. What is remaining here? Cos nx, applying limit 0 to pi. Now further you can write multiply minus 4 divided by pi square n square bracket cos n pi minus cos 0, upper limit minus lower limit, minus 4 divided by pi square n square bracket cos n pi is minus 1 raised to n minus cos, you can write like this. So this is the answer for an. Okay, finally we got a naught, an, and bn is already 0 because we have told that it is an even function. So therefore the required Fourier series is f of x is equal to a naught by 2 plus summation n from 1 to infinity an cos nx plus summation n from 1 to infinity bn sin nx. Okay, so we got the answer as a naught as 0 and plus an we got as like this. So summation n from 1 to infinity, so minus 4 divided by pi square n square minus 1 raised to n minus 1 bracket cos nx plus this is the required series, which is required series. Now let us discuss the third example. Obtain the Fourier series of the function f of x is equal to, again I have taken an example of a double function, but the interval I have taken as minus pi to plus pi. So how to solve this step? Again an example, as I told you, if it is given in a double function, so you start with example, let phi of x is equal to the first function x minus pi by 2 and psi of x is equal to the second function x plus pi by 2. If the interval is given minus pi to plus pi, so put x is equal to minus x. You substitute any one of this. So minus x is equal to, put x is equal to minus x minus pi by 2. So I can write minus as it is. If I take minus common, so x plus pi by 2 remain. So shall I write like this? Minus as it is, and this is x plus pi by 2 is nothing but is a psi of x. So therefore Cn, you got phi of minus x as minus psi of x. So therefore the function becomes, you go through the note which I have given for this one. The function is odd. If the function is odd, a naught an becomes 0. Only you need to find bn. So therefore bn formula is given as 2 divided by pi integration 0 to pi f of x into sin nx with respect to dx. So 2 divided by pi integration 0 to pi f of x. F of x you have to take 0 to pi. Which is 0 to pi? This is 0 to pi. X plus pi by 2 into sin nx with respect to dx. So 2 divided by pi bracket. Okay. First function as it is. Integration of sin is minus cos nx divided by n. Okay, then minus differentiation of this one is 1, again integration of this one is cos ka integration sin nx divided by n square bracket applying 0 to pi. As we know that this function becomes a 0. Okay. This function becomes 0. So when you apply sine, it becomes a 0. So therefore remaining term 2 divided by pi bracket, so divided by n pi. So x plus pi by 2 into cos nx applying 0 to pi. Okay, now minus 2 divided by n pi as it is. Now apply upper limit pi. If you apply this pi plus pi by 2, then cos n pi upper limit minus, when you apply this, it becomes pi by 2 cos 0, because if you substitute this becomes 0. So further I can write like this, that is minus 2 divided by n pi as it is, bracket. So pi plus pi by 2 is nothing but 3 pi by 2, cos n pi is minus 1 raised to n, then minus pi divided by 2 cos 0 is 1. So therefore, so you can write like this, minus 2 divided by n pi, bracket. So pi by 2, if I take a common, pi by 2 outside, what is remaining? 3 minus 1 raised to n minus 1. Okay, so 2 get cancelled, pi get cancelled, so minus 1 divided by n into bracket 3 minus 1 raised to n minus 1. So this is the value for bn. Okay, so after getting this bn, therefore the required Fourier series is given by f of x is equal to a naught is 0, an is 0, so therefore bn is summation n from 1 to infinity, bn is minus 1 divided by n, 3 minus 1 raised to n minus 1 into sin nx. So this is required Fourier series. Okay, so these are the examples which I had solved in odd and even concept, uh, by taking interval minus pi to plus pi. Now let us discuss in the next lecture, that is odd and even concept in the interval 0 to 2 pi. If it is given 0 to 2 pi, what is your substitution, how you can calculate odd and even, how you can check the odd and even function. Okay, thank you.